Dear learners, we are going to see about the basics of semiconducting materials. I am Dr. T. Jayanalina, Professor and Head, Department of Physics, Nanda Engineering College. In this session, we are going to discuss about how the materials are basically classified. Materials are classified into three types: conducting materials, non-conductors or insulators, and semiconducting materials. Conducting materials are the materials which allows electric current and heat to flow through it. Non-conducting materials are the materials which do not allow electric current and heat to flow through. There comes a special type of material called semiconducting material. Semiconductors are insulators at 0 Kelvin. Basically, they are insulators, but they get the property of a conducting material under two conditions. Condition number 1 is by adding impurities, and condition number 2 is by increasing the temperature. So, what do you mean by conducting material? Or we can say that the materials are classified based on the energy gap. What do you mean by energy gap? Energy gap is the gap between the valence band and the conduction band. In conducting materials, the energy gap is zero, or we can say in turn, they overlap with one another so that the electrons from the valence band can directly get into the conduction band, which results in the flow of current. Whereas in non-conducting materials, the gap between the valence band and the conduction band is too large, which will not allow the electrons from valence band to reach the conduction band, which does not result with the flow of current. In semiconductor, we can say the energy gap is neither as small as in the case of conducting material, nor as large in the case of non-conducting material. Examples of conducting materials are silver, aluminum, etc. Non-conductors example were wood, glass, etc. Semiconductors, germanium and silicon are the basic examples of semiconductor. Now let us discuss about the properties of semiconducting material. Semiconductors have the resistivity with the range of 10 power minus 4 ohm meter to 0.5 ohm meter, which lies between the resistivity of conducting and non-conducting materials. Their band gap is approximately equal to 1 electron volt. They have the special characteristics called negative temperature coefficient of resistance. It means when the temperature increases, conductivity increases and resistivity decreases. They represent in the form of crystal structure. Classification of semiconductors. Semiconductors can be classified into two types based on the elements present in them. They are elemental semiconductor and compound semiconductor. Elemental semiconductors are the semiconductors in which only one element is present, example germanium and silicon. Compound semiconductors are the semiconductors which are formed by the combination of the elements from third and fifth column of periodic table, example gallium arsenide and gallium phosphate. Elemental semiconductor, there occurs a recombination of electrons and holes through trap, which means indirectly. So it can also be called as indirect band gap semiconductor. Compound semiconductor, the recombination of holes and electrons occur directly, so the name is called as direct band semiconductor. They are used elemental semiconductors during the recombination. Phonons are emitted. Phonons are energy. Whereas in compound semiconductor, recombination of electrons results with photons, light energy. And examples we can say in elemental semiconductor, it is nothing but germanium and silicon, and compound semiconductor, gallium arsenide and gallium phosphate. The application of elemental semiconductor is to manufacture diodes and transistors. Compound semiconductor finds its application in LEDs and laser diodes. Next is the classification of semiconductor based on their purity. Based on the purity, you can classify the semiconductors into two types, N-type and P-type semiconductors. Semiconductors can be classified into two types based on their purity. Pure form of semiconductor is called as intrinsic semiconductor, and impure form of semiconductor is known as extrinsic semiconductor. Impure form of semiconductor can further classified into two types, N-type and P-type. N-type semiconductor is got by doping the pentavalent atoms in it. Pentavalent having 5 free electrons, and P-type semiconductors are got by adding trivalent atoms in it which possess 3 valence electrons. So N-type semiconductor, we can say that the donor energy level is just below the conduction band And p-type semiconductor, the acceptor energy level is above the valence band. In n-type semiconductor, as we have donor electron, it can also be called as a donor energy level where it is present. And pure form of semiconductor is called intrinsic semiconductor, where germanium is the best example for it. And we can say in germanium, the electrons are inside the covalent bond, where by increasing the temperature, they broke the covalent bond and come out of the bond with a free electron, which results in the formation of flow of electrons, and flow of which results in flow of current. And finally, we are going to see about Hall effect, which gives you or which discriminate the types of the semiconducting material or conductors or insulators. So definition for Hall effect is when a material or when a semiconducting material is perpendicularly placed in a magnetic field, an electric field is induced in it, and the induced electric field is perpendicular to both the current flowing through it and the magnetic field. This effect is called Hall effect, and the voltage induced is called Hall voltage. Using the coefficient, Hall coefficient, sign of the Hall coefficient, if RH is positive, it is a p-type semiconductor, and if RH is negative, it is n-type semiconductor. Hall effect is also used to find out the charge carriers, and also used to find out the charge of the concentration of the charge carriers present in it. Thank you.